好啊，大家好，早晨啊，歡迎大家咧嚟臨出席呢一個記者會㗎。咁亦都非常之唔好意思啊，因為開學嘅關係咧，所有大嘅會場都 occupy 咗，所以今日比較逼。同埋一陣間記者會之後咧，我哋參觀實驗室咧，嗰個環境都係會比較逼嘅，所以咧就抱歉，但係多謝大家嘅出席。咁咧或者開始前咧，我簡單同大家講解下今日記者會個流程好嘛？咁咧我哋咧第一個鐘頭咧會留喺呢個房間就進行呢一個記者會嘅。咁啊，時間係要攞得好緊嘅。1個鐘頭之後咧，咁我哋就會係去移步咧，係去到我哋嘅實驗室。咁嗰度咧，我哋都有分2個實驗室，有戶外、戶內。不過詳情一陣間咧，臨散呢個場之後，之前我哋再同大家講解。咁喺呢1個鐘頭嘅記者會裏邊咧，主要係分開3部分嘅。第一部分呢，我哋會花大約30分鐘嘅時間，咁我哋好榮幸有4位講者咧，為大家分享一啲重要嘅一個項目嘅信息先。咁接住落嚟呢，就其實我哋今日在場都有好多嘅團隊嚇，係喺大家聚首一堂。咁我哋咧會一齊做一個合照先。咁所以咧，記者朋友如果需要影相咧，可以一齊同我哋影咗個合照先。咁跟住我哋就會找緊時間咧，希望可以用到15分鐘大概嘅時間咧，就係做一個發問嘅。咁一陣間發問嘅時候咧，就除咗我哋嘅講者唔能夠用普通話之外咧，大家係歡迎用廣東話或者係英文發問。咁我哋講者咧都係盡量係用返大家嘅語言嚟到作答。咁如果咧大家都對呢個流程係掌握咧，咁或者我首先咧就藉呢個時間介紹我哋今日嘅4位講者。咁其實咧嗰個名稱都喺新聞稿同埋喺而家呢個熒幕嗰度㗎啦。我介紹咗先，咁跟住就會將時間交俾佢哋。咁我哋咧一陣間第一位講者咧係香港科技大學環境研究所所長劉啟漢教授 Professor Alexis Lau 嘅。咁跟住落嚟咧，我哋係有香港環境保護署助理署長空氣質素政策梁啟明博士 Dr. Kenneth Leung。接住落嚟咧，我哋有加州大學爾灣分校嘅 Professor Donald Blake。最後咧，我哋有嚟自赫爾辛基大學嘅教授，同埋咧 Aerodyne Research 副總裁 Professor Douglas WORSNOP 嘅。咁事不宜遲啦，唔好意思，咁咧一陣間劉教授咧，佢係會為大家咧進行解釋一個背景嘅資料啦。咁而 Dr. Kenneth Leung 咧就會為大家解釋呢個大型合作嘅細節，係非常之重要嘅內容。咁而 Professor Donald Blake 咧，佢就會係為大家講解我哋今日嘅主題啊，有關於臭氧啦，同埋嗰個揮發性化合物嗰個複雜性係喺邊度？呢個亦都係考大家要去留心聽。咁最後 Professor Douglas WORSNOP 咧就係會介紹咧咁困難做嘅研究裏邊咧，點樣係結合最新科技同埋唔同範疇嘅技術咧，係去解決呢個問題嘅。咁事不宜遲，我而家將時間交俾Professor Alexis 啦，唔該晒。
好，首先都再多謝各位今日喺咁短時間之內即係嚟到啦。咁我諗頭先Michelle 都解釋過，因為其實亦都係因為好短時間 call 呢個press briefing， 咁所以就即係地方就真係大學唔係好應該即係咁窄嘅地方。但係點都好，其實今日點解咁急叫大家嚟呢？咁當然我嚟科大都係一件好事嘅，呢度咁靚嚇。咁另外一樣嘢呢，就係我哋都科大已經喺今個學年已經話 everything back to normal 復常啦。咁所以好多活動應該都會繼續咁去。咁但係呢兩個都唔係一個理由叫大家入嚟嘅。其實呢，最主要好明顯，我哋係有一個都幾嚴重嘅問題。咩問題呢？咁其實呢幅圖我諗大家可能都已經睇過好多次㗎啦。呢幅圖就係喺過去嗰幾年，尤其是你睇到咧，呢度就係由2011年去到舊年年尾咧，唔同污染物個年平均值，如果我哋用2011年做基數，究竟升咗抑或跌咗？咁你睇到咧，其實好清晰咁睇到咧，就係大部分嘅污染物都跌咗好多嚇。咁唯獨咧有一個臭氧就 佢個平均值咧升咗34%。咁呢樣嘢咧，我諗大家都即係過去都問咗好多次。咁而呢個問題咧，其實喺上個星期咧係好嚴重。嗱，呢一幅圖咧，大家可能未必見過。咁其實好多年前，我哋同政府同中文大學一齊發展一個叫做空氣污染健康指數嘅時候咧，就已經開始有幅咁嘅圖啦。不過大家可能就未必睇開。咁呢幅圖第一樣睇到咧，就係香港唔同地方嗰個空氣質素係幾多。咁而個顏色咧，黑色咧就係叫做嚴重，而呢個深啡色咧就係非常之高。咁你睇到咧，其實全香港所有站咧都係嚴重或者係非常之高。咁另外呢邊呢啲咩咧？好似即係我哋以前 Pac-Man 嗰啲咁嘅嘢啦。咁其實就係話，因為呢個空氣質素健康指數咧係講健康風險嘅，咁係唔同污染物嘅健康風險計出嚟嘅。咁呢度嘅顏色咧就其實代表唔同污染物個健康風險有幾大。咁你由呢度睇咧，你其實見到呢隻 Pac-Man 咧，就好多嘢都係黃色嘅。黃色係乜嘢咧？黃色就係臭氧。其他嘅譬如有幾個站可能喺市區裏邊咧，就有啲淺藍色。淺藍色咧就二氧化氮。咁你睇到咧，其實喺呢啲咁嚴重嘅空氣污染嘅日子咧，最主要就係臭氧。咁市區仲係有啲二氧化氮。咁呢度咧只係一個時間嘅啫，但係如果你睇翻成個星期咧，即係由9月1號開始，一路至到9月19號，琴晚夜晚，你會見到其實呢度我攞咗個站出嚟喺中西區，咁就係如果你跟翻啲顏色嚟睇咧，綠色就良好啦，呢個就中等，紅色就係高，然後呢度咧就非常高，跟住就係嚴重。你睇到9月咧，其實有好多日子，差唔多每日都去到高嘅位，而嚴重咧，亦都有好多日啦。咁最重要亦都下邊呢一幅圖咧，下邊呢幅圖就係話，究竟呢啲數啊，呢啲咁嘅所謂健康風險係邊個污染物產生嘅咧？咁你會睇到咧，其實唔同嘅污染物，我哋成日講臭氧啦、二氧化氮啦、PM2.5、SO2， 其實如果講健康風險，短期嘅健康風險咧，其實你睇得到，全部差唔多都係奧松搞出嚟嘅。咁所以咧，其實奧松好明顯係一個我哋非常需要面對嘅問題。咁 OK， 既然我哋有問題啦，咁有咩辦法做咧？我想 make 呢句 statement， 我哋係喺全世界裏邊揾咗最頂尖嘅專家，做最深入嘅研究。香港、珠三角、世界裏邊最頂尖嘅專家，我哋一齊揾咗佢嚟。環保署一陣間咧就會講出嚟，就係話究竟係講緊啲乜嘢？呢個Kenneth 一陣間會講。OK。咁今日我想大家請大家入嚟，有幾個 take home message， 我想大家留意嘅。第一樣，我哋的確有一個似乎係越嚟越差嘅臭氧問題，但係咧呢樣嘢真係好複雜。一陣間 Professor Don Brick 會提到究竟呢樣嘢點複雜法咁另外咧就係、Kenneth， 我希望都會講得到，其實真係會做緊好多唔同嘅人做緊好多嘢。咁我哋相信科學係可以解決呢個問題嘅。喺第二度亦都係有好多試驗，亦都係做過。咁但係咧，唔同地方有唔同嘅複雜性。咁我哋覺得 science 一定可以幫手解決呢個問題。咁我哋自己喺學校咧，我亦都想講其實好多呢啲大型嘅實驗咧，對於學生嚟講，對於我哋嘅團隊嚟講係好緊要嘅，因為呢啲大型嘅實驗，我哋可以睇得到每個學生自己雖然做嘅嘢好雜，但佢睇到佢做嘅嘢點樣可以喺一個 大型嘅項目點樣可以實際喺社會裏邊用得到呢？呢個經驗呢，我哋覺得佢第時畢完業做第二樣嘢嘅時候呢，其實係好有用。即係呢一類咁嘅 project，我哋真係覺得喺學生嗰個無論係 professional，抑或係 leadership 嘅 development 咧，非常重要。所以我暫時講住咁多啦。咁而家咧就交翻俾阿 Kenneth。
我就冇 PowerPoint 嘅，可以開翻少少燈啊。咁多謝阿 Professor Lau 嘅介紹。究竟我哋嘅問題啊，尤其是係過去嗰一個禮拜、2個禮拜，其實延續咁樣有一個臭氧嘅問題。咁係咪年年都係咁差呢？我哋明白咧，其實喺我哋嘅首要污染物咧，我哋已經係減少咗好多啦。咁頭先喺嗰個圖都見到，無論係二氧化氮、二氧化硫。甚至 PM2.5，我哋都係減少緊嘅。但係喺嗰個二次污染，臭氧係一個二次污染嚟嘅，即係話佢唔係噴出嚟嘅，佢係喺一次嘅污染物喺大氣底下，佢經一個太陽嘅刺激，喺一個光化學作用底下呢，佢再產生出嚟。咁所以呢，我哋係需要知道究竟佢係邊幾種嘅一次污染物呢係產生。咁同埋呢一啲咁嘅情況，點解會今次咁延續咁長嘅時間呢？係主要係因為個氣象狀況。其實由9月1號到而家，我哋係不斷受幾個颱風嘅影響。唔同嘅颱風去緊台灣嘅時候呢，都會引致呢成個我哋叫大灣區啊嗰個氣象條件都會變得差嘅。點差法呢？就係佢個風速會比較慢啦，弱咗啦。佢個好多時啲污染物走出嚟之後呢，只係會困住喺大灣區裏邊，仲要係連續咁長嘅時間呢，你啲污染物就會一路累積，一路累積，然後去到最後呢一個禮拜呢，就變成呢係日日都會係比較高臭氧嘅情況。嗱，呢一個咁嘅情景呢，我哋喺過去已經係了解到有呢個問題。我哋都知道呢，臭氧係其中或者暫時嚟講呢，係最後一個呢，我哋喺空氣污染裏邊呢未解決嘅問題。呢個亦都係一個區域性嘅問題，唔係淨係香港做咗嘢呢就可以處理咗嘅。因為呢個範圍呢係講緊成個大灣區嘅範圍，係咁大嘅一個範圍，所以要解決呢個問題呢，其實喺前年香港特區政府同廣東省政府，加埋澳門特區政府呢，其實我哋聯合決定呢係進行呢一個咁樣嘅跨區域性嘅臭氧研究，就係一個大灣區嘅臭氧研究。個目的係做一個咁嘅研究呢，係攞到足夠嘅科學數據，去俾我哋更加了解喺我哋嘅區域裏邊個臭氧成因啦，佢個傳輸軌跡係點樣啦，等我哋係更加準確可以知道究竟我哋將來要管制邊一類型嘅污染物排放，而更加有效咁樣可以改善我哋嘅臭氧問題。好啦，咁我哋成立咗呢一個嘅目標之後呢，咁我哋要進行一啲嘅工作嘅。咁所以我哋開始去計劃我哋究竟呢一個嘅研究項目點做。咁我哋參考嗰個以往嘅做法呢，其實我哋知道唔可以單靠一個團隊呢去可以完成晒咁多嘅工作，其實係好複雜嘅問題。所以當我哋設計嘅時候呢，呢一個嘅研究範圍係好大嘅，成個嘅研究工作係覆蓋成個嘅大灣區範圍。所以我哋喺成個大灣區範圍呢，都會用一啲嘅高端嘅監測儀器去採納空氣裏邊一啲嘅污染物嘅濃度啦，同埋佢嘅成分。我哋唔單止需要知道佢濃度，我哋要知道佢成分，因為有啲揮發性有機物嘅成分咧，其實係好多種類嘅。究竟佢裏邊嘅成分係乜嘢呢？ PM2.5 佢裏邊嘅成分又係啲咩嘢咧？我哋需要知嘅。咁所以我喺過去呢2年裏邊呢，我哋係採購咗好多比係相當尖端嘅一啲嘅監測儀器。咁陸陸續續咧喺今年咧開始嚟運到嚟香港啦。我哋慢慢咧亦都開始擺佢喺唔同嘅地點咧，係進行一個實時嘅監測。我講緊係實時嘅監測，我哋唔係淨係攞一個採樣，然後翻去個實驗室。我哋實時知道究竟佢個變化係點樣。除咗一啲污染物嘅監測之外咧，我哋亦都購置咗一啲激光雷達。 激光雷達咧係可以監測喺上空咧，因為呢啲臭氧嘅情況，你好多時見到咧，唔係淨喺地面嘅，你望出去成個天都係灰灰暗暗嘅。咁其實我哋知道佢係一個立體嘅問題嚟嘅。咁要處理一個立體問題，你唔可以靠地面嘅數據咧係幫助到你。所以我哋嘅採樣亦都係立體嘅。LiDAR 即係呢個激光雷達咧，就幫我哋可以監測上空裏邊嘅臭氧啦，同埋一啲 PM2.5，即係嗰粒物佢嘅變化啦。仲有我哋都度埋個風嘅，即係話用一啲嘅激光嘅風雷達啦，去睇個風確線，究竟上空嘅風嘅變化係點樣，同地面有冇好大嘅分別？除咗呢兩樣之外咧，我哋亦都做一個我哋叫 campaign 啦，一啲嘅特別嘅實驗日子。點為之特別實驗日子咧？就係好似過去呢幾個星期咁樣，我哋喺啲高污染嘅日子揀咗某一日，我哋會係同步喺成個珠三角裏邊揀80個點，係同一日喺呢80個點去採樣，用一啲採樣罐去採樣，喺唔同嘅時段攞一啲嘅樣品。呢啲嘅採樣罐咧就會幫我哋知道究竟佢裏邊個空氣裏邊嘅揮發性有機物嘅濃度同埋嗰個種類嘅。咁呢一個動作咧係要之後翻去實驗室做化驗。但係當我哋當嗰日採樣嘅時候咧，喺香港我哋亦都會派船走出去我哋嘅水邊。點解要係派船出去呢？因為我哋都過往嘅經驗都知道，其實大部分嘅臭氧咧會留喺海上邊嘅，同埋好多個前期物咧都係留咗喺海上邊。以往咧我哋監察唔到，所以咧喺今次呢一啲咁樣嘅監察嘅 campaign 裏邊咧，我哋會派船走出去，亦都係同喺整天裏邊咧係攞樣本同步。今次都幾個特別嘅，我哋同香港嘅飛行服務隊合作，佢哋將一架直升機改裝，係將我哋嘅儀器咧監察儀器放上嘅直升機裏邊。所以當我哋做一個咁大規模嘅監測嘅時候咧，同一時間咧，我哋都派直升機喺上空飛，喺香港嘅上空飛，喺攞上空嘅樣品，幫我哋都知道咧，究竟上空同地面或者海面嘅分佈係點樣。除此之外咧，攞咗呢啲採樣罐翻嚟啦，咁我哋去邊度做分析呢？咁亦都有賴 ITC 啦，即係我哋資訊科技處啦，係資助咗咧科大咧就成立咗一個 VOC Lab 嘅。咁呢個 VOC Lab 咧亦都多得阿 Don Brick 教授咧係幫手去成立嘅。咁佢個係一個好高規格嘅實驗室，幫我哋可以咧係分析呢啲採樣罐裏邊嘅 VOC 成分，去到好微量都可以做到嘅。有咗個 lab 之後咧，我哋就會知道究竟我哋攞翻嚟嘅樣品嘅成分啦，甚至佢嘅地域嘅分佈。因為每一個地區呢個 VOC 組分都可以唔一樣，咁我哋就知道究竟邊啲地區可能佢個排放某一種嘅揮發性有機物係特別多啊，甚至咧咁有咗呢啲咁樣嘅數據之後，我哋都仲有一個 missing piece 嘅，仲爭一個方塊。究竟佢個傳輸軌道係點嘅咧？所以我哋都有隊模型嘅團隊 modeling team。呢個 modeling team 咧就係會幫我哋去分析究竟呢啲嘅數據同如果用模擬加埋氣象去做一個配對嘅時候，佢喺邊度嚟咧？去產生嗰個化學個過程係點樣咧？俾我哋去印證究竟個背後嗰個化學變化。嗱，呢個模型團隊仲有一個嘅角色嘅。呢一樣嘢，我相信喺世界上咧都好少咁樣去做一個咁樣嘅實驗。呢個模型團隊係負責預報嘅角色，因為我哋要捉嗰個高臭氧日子，我哋要定點，我哋要定到邊日去做實驗嘅。而做實驗嗰日咧，一定係需要高臭氧嘅。咁所以呢個模型團隊咧，當我哋一入到8、9月咧，就會不斷去睇住佢哋嘅模擬結果，佢哋要做預報。如果佢能夠做到7天之前話到俾我哋聽，7日後有機會有一個咁樣嘅高臭氧情況，成個團隊就會準備啦。咁所以咧，我哋係好有能力咧，係可以好準確揾到嗰個日子嘅。但係咁多工作咧，唔係一個團隊做晒，亦都唔係政府可以做到。有賴咧，在座有好多唔同大學院校嘅教授幫手，除咗阿劉教授佢哋嘅團隊啦，有城大陳澤強教授啦， 有中文大學何建輝教授，亦都有理工大學李順成教授喺嗰邊同。咁其實我哋有4間大學係一齊幫手，去幫我哋咧去進行今次呢一個咁樣嘅計劃。呢個實驗計劃唔係做一次嘅，我哋係做3年，每年做一次咁樣大規模嘅同日嘅監察，亦都喺中間嘅時間咧係不斷去做呢個每日嘅實時嘅監察，不斷收取數據，幫我哋了解好嘅日子係點樣咧，唔好嘅日子係點樣，而有一個對比。咁最後咧，亦都成個呢啲數據咧，唔係淨係我哋分析，我哋亦都成立一個科學嘅專家督導小組嘅。呢個督導小組由8位專家係組成嘅，有2位係中國嘅應該係科學院應該係工程學院，應該中國嘅工程學院2位院士，侯吉明院士同張宇航院士，再加4位國內專家同埋2位本地嘅專家。其中1位係劉教授，係我哋嘅科學嘅督導小組，幫我哋去指導咧成個研究嘅設計咧、進程咧，同埋咧一啲嘅科學數據嘅分析嘅。所以我好多謝咧各位專家嘅幫手。如果冇你哋幫手咧，其實我哋好難去圓滿咧去進行呢一個嘅項目。亦都多謝 Professor Don Brick and Professor Doug WORSNOP， 佢哋俾咗好多專業嘅意見，去指導我哋點樣去用好多好先進嘅儀器，同埋喺處理數據啦，係處理嗰啲 VOC 分析裏邊點樣去做得更加精準嘅。咁所以咧，我哋覺得咧出年會有下一個 campaign 嘅。咁未來咧所收集嘅數據會更加豐富。我期望咧香港同國內同廣東省政府同埋澳門呢個項目咧，可以得出一個好豐富嘅數據庫，唔單止解決我哋香港或者珠三角呢個大灣區嘅問題，將來呢一個嘅結果，亦都可能幫助到咧國內去研究同樣嘅問題時候，有一啲多啲嘅資料去幫助佢哋去諗嘅。好多謝大家，我以下時間交翻俾 Michelle。
唔該晒 Kenneth 詳細嘅解釋。咁頭先嘅內容都係新聞稿裏邊大家可以揾到嘅。而頭先 Kenneth 提到嘅咧嗰個海陸空嘅研究啊，同埋個激光雷達咧，陣間都大家可以喺參觀嘅時候睇到。咁非常之好。Okay, so let us introduce Professor Don Blick and let Professor Don Blick from UC Irvine to share with us the issue of ozone and VOC complexity. Yeah, I will turn off the light.
Thank you. Doug and I completely agree with what Kenneth just said. Completely. Okay. Okay, so maybe if this light can be turned on. Okay, all right. Okay, so this is just the particulars. Oops, wrong way here. For where I am. And this is Hong Kong. And my group is involved in ozone-related science. This is the aerosol part, which actually seems to be getting better here. Let me see, next slide. This is just to show the experience that my group has. These are some, not all, but some of the NASA airborne projects that we have flown over the last 35 years. The one right here, MWest-B, was
Sorry,
actually...
Don, we can't hear you.
Can't hear me?
Sorry.
Okay, I thought I was being loud. Do I need this now? Oh, okay. Sorry, should I start over? No need to start over, Doug? Okay. Well, anyway. But this particular project was PemWest-A and PemWest-B, and we actually collaborated with Hong Kong PolyU on that project. Okay, next. Geez, I'm making noise. Maybe I'll move over here. Okay, so my job today is to illustrate the complexity of the ozone problem. Alexis showed that things were, in this last week, nothing was alarming except for the fact that the ozone was bad, and it was responsible for all the health problems. And so this is, oops, wrong way. This is just sort of a cartoon, very simplistic. If it were this easy, they wouldn't need this guy, okay? but it's very complicated. And so I'm going to be talking about VOCs. And VOCs, I'll show you in a minute what they are. But the VOCs can react with hydroxyl radical, which is made by the sun, then can react with NO, which is given off by cars, and make NO2, and then this can be photolyzed and you make ozone. So that's the absolute sort of high school level chemistry. Also notice that off this cycle can come secondary organic aerosols. These are very important and they're very bad for you because they're tiny and they can cause health problems. But I'm going to be talking about just this. And VOCs have many different sources. This is a list of some of the gases that my group measures and that the group downstairs or in the lab, Das's lab, can quantify. And we have very many different types of gases. So we have, some of these are what we call sort of long-lived. Long-lived means that they stay in the atmosphere more than a few minutes or a few hours or a few days. So these are all different classes of chemical. These over here are greenhouse gases. And so it's as I said, these are just some of the gases that are measured. And so it's important that we measure as many and come up with what the concentrations of these gases are. So this is a bar chart showing 4 different cities. So we have Lahore, Pakistan, Mecca in Saudi Arabia, Hong Kong, and Seoul. And so this picture slide is to illustrate just how different things are. Let's look first at Lahore. The top 2, these are the concentrations. The highest concentrations are at the top. So if we look at there, ethine and ethene are the highest concentration gases in Lahore. Let's look over here. We'll go to Mecca. Well, here's ethine and here's ethene, so it's less important. Ethine, ethene right there, ethine, ethene right there. So this area is very different. If we go to here, and mainly these are from the tailpipe of the car. Okay. If we look at Mecca, they have a huge isopentane from gasoline. Isopentane is number 3 in Lahore, and it is here in Hong Kong, and here in Seoul, and so on. Okay, very different sources. Here we have a lot of butane because we have a lot of LPG. Less gasoline, more LPG. So our signal looks different, and Seoul looks different. So what's the point of this? It's saying that no place is the same. You have to have an approach for a city that is specific to that city. Okay, and in fact, it's possible that one in like Central, that Central looks different from Kowloon. So once again, it's trying to solve this problem. Trying to reduce ozone is a hugely difficult situation. Doug will be talking about some incredible instrumentation that his company's made that someday might be telling us what VOCs we should be measuring, because we maybe aren't even measuring the right ones. So we work together on this type of thing. Okay, so once again, my job, oops, wait a second. I'm missing a slide. I guess I took it out. I had an isopleth to show you. Okay, well, anyway, the point is that it's complicated. We have NOx, we have VOCs, and if I had not gotten rid of the slide that I thought I had, I would show you how reducing one actually can make ozone increase. Okay, so I'll see if it's at the end of the slides, but anyway, if not, I'll just go to, this is a photo taken about 3 years ago in my laboratory, okay, and my 2 colleagues here who are at the back of the room, Simone and Brent, and a colleague Gloria, but here we have UST professors. We have Peter Louis from Hong Kong EPD, and then we have 2 colleagues from the private sector here. Collaborations are critical. This is a photo here 3 years ago. This is Vincent from the EPD, and then me, and then my 2 colleagues here. And in this room, folks, in this room, we have sort of the brain trust of Hong Kong atmospheric sciences, okay, ozone chemistry. And so this problem is not going to solve itself. It's going to require a lot of work. And fortunately, we have the gunpowder, or the big guns, to at least start getting a handle on this ozone problem. With that, oops, okay, well, I don't know what I did with that slide, but anyway, thank you very much.
Thank you very much, Professor Don Blake. So now let us have Professor Douglas WORSNOP to give us an important presentation.
Okay. Could I actually have Don's last slide?
I didn't do a good enough job?
Actually, the slide I wanted was Professor Lau's second slide, but this has the same information on it. Well, first, it's great to be here. This is the first time I've been back in China for going on 3 years, and it's just wonderful to be here. And what I wanted to start out by saying is, if you look at the left-hand side of this, the left-hand graph, this is good. Just to emphasize this is a success story. But the right-hand side is a failure, or a problem. That's a better word. Problem. And to re-emphasize, agree with everything that's been said in both Chinese and English, the reason we're here is that this is complicated. In solving not solving, but significantly reducing the PM problem, we have made, well, in fact, the ozone problem has gotten worse. And this is not unique to Hong Kong. This is, everywhere in Asia right now, more or less. And again, it's complicated, and I'm going to give an overview of why I think all of these big guns can help. So, is there any way I can get my talk up here now? Because I don't really need this slide anymore. Just remember, it's complicated, as everybody else has been saying.
Let me fix your...
Fine. I would rather use this. Yeah. Can we make it smaller so I can see the whole thing? Yep, perfect. Okay. Okay, this is a bit of a speech, but I'm going to break it up. To start out with, I believe that the investment in air quality research that we've heard about today really has the potential to significantly improve the science that underlies the air pollution, ozone, and haze. The cutting edge instrumentation will dramatically improve our understanding of the molecules that are doing the action. I'm actually a professor of physics, but I'm really a chemist, and I really think in terms of molecules. And the molecules I think of mostly are the ones that happen after the VOCs that Don talked about. Because as soon as all those VOCs get into the air, they get oxidized into all kinds of stuff. Literally thousands, tens of thousands of molecules. And it's those molecules that both lead to ozone production and lead to aerosol formation. So I'm all about molecules. And the fancy mass spectrometers that my group and that have been installed here, that's the important thing. I mean, we try to measure fingerprints of all of the chemistry, from the vapors to the aerosol, the composition of the particle, the condensed haze particles, from the emissions to the processes that control the ozone and particle formation. And what we do is we get those fingerprints in real time, continuously, hopefully over weeks and months. And then it's completely complementary to what our canister samples that Don Blake was talking about, Professor Blake was talking about. He gets more quantitative, detailed information of the VOCs, but we get real-time information of what they do. And you really need all of that information to really figure out that complexity. We're talking about unraveling, resolving the complexity of both the ozone and the particles, because in the end they're all connected. They're connected by the emissions and the sunlight that bakes them. Now, in order for a project like this to be successful, we need a new generation of scientists who can actually operate, analyze, and interpret all these measurements. I can't emphasize that too much. This has to be done by people. We get a lot of data, and you need a lot of people, and they're all, in the real world, they're all young people who do the real work to figure out. If we do not really analyze this data, it won't mean anything. And this requires hard work, dedication, and extra scientific training and insight for every student, for every postdoc, even every professor. This is what it's about, from my point of view. And furthermore, there has to be a real need, a strong collaboration among all the research groups and the agencies. This includes all the students and postdocs and all the academic groups. And then eventually, we also need the meteorologists and eventually even the computer modelers, okay? But all the data, I mean all the data, not just of these fancy instruments, all the meteorological data, the LIDAR data that Dr. Leung talked about, needs to be completely integrated. I mean, we're going to make detailed chemistry, I mean, what I'm going to call unparalleled, in-depth molecular measurements. But unless we put it all together, or putting it all together is required for real innovation. It's about the air. It's not really about the molecules, per se. It's really about using the molecules to understand the air. And that means the whole air. In Hong Kong, that means, as Don mentioned, I mean, Hong Kong is, for sure, inhomogeneous in a lot of the chemistry. And then you can extend that to the Greater Bay Area. So we really need deep collaboration among the entire air quality science community. That's both the academic and government. I mean, but it's this holistic approach that is required. And we're bringing, as you said, a bunch of big guns. We're bringing a lot of instruments and a lot of potential information, but we have to use it. And I could say in summary, this project has the potential to serve as a model of air quality study all over China and beyond. I base this on the fact, I mean, just like Don, I have participated not in aircraft campaigns, but ground-based campaigns where we measure the air all over the world, for the last 20 years. I mean, and all over the world concludes in many sites, many campaigns in China. I mean, to reiterate, this investment in what I call resolving the molecular complexity has the potential to be the most comprehensive study in the world. It can be a model for the future. But you need multi-team, multi-expertise, collaboration to address the ozone, to resolve the ozone and haze problem. As Professor Lau said, the science is the answer. I totally believe that. He also said slowly and surely, because it doesn't happen overnight, because the complexity is really there. So I congratulate HKEPD for coordinating this whole study. I'll make another comment. I've been studying, the smog problem was first recognized particularly in London and Los Angeles in the 50s and the 60s. I started getting involved in this in the 80s. And in the United States, we have cleaned up the air, mostly. Not completely, but it took us 40 years of the Clean Air, 50 years of the Clean Air Act. And the point is, when we were at your stage, the more polluted stage of the problem, but exactly this, when you were right in this end, we have high PM and high ozone. We didn't have any of these toys, any of these instruments. This is the opportunity now, starting in Hong Kong, to use the best instrumentation to do it better, to do it faster, to understand it better. As Don said, if we don't know exactly which emissions are the most important, and as Don said, every place is different. So you actually need to do this everywhere. So I'll just repeat it once again. This will only be successful when the training, the efforts, the hard work of all the young people in multiple disciplines, in multiple institutes, are brought together in a dedicated collaboration for years, okay? I'm here specifically because I want to help support that. I spent most of my career working with students and postdocs on the data. I want to see, would love to see, a real integration of this whole project, including the meteorology and the LIDAR, all the different sites. That's what I believe in Hong Kong, we can really make a difference. And I'll just say thank you.
Thank you very much。多謝晒 Professor WORSNOP 嘅。咁啊，正如 Professor WORSNOP 講啦，咁為咗慶祝我哋今日咧，大家唔同團隊聚首一齊咧，咁不如我哋而家做一個合照先嘅嚇。咁我想請，因為我哋人多要分兩行，我想請科大團隊同 EPD 朋友啊，除咗 Kenneth 就可以 take 第一個 step。OK 未？好，最後一張 last photo。係咁，一陣間請大家咧可以用自己嘅可以介紹自己係嚟自邊一個媒體咁樣嘅。係啦，咁啊 speaker 都 ready， 不如坐得唔係幾齊整。哦 OK，yes， 得啦。係請問邊位有問題想發問㗎？有冇邊位係？
Hello， 我係南方報業傳媒集團，想請問一下梁博士，係呢一個項目佢嘅推進有冇一個具體嘅時間表，同埋一個最終出嚟嘅結果有冇一個預期嘅時間？
係嗱，其實嗰個時間表，我哋成個項目咧，舊年已經做咗第一次嘅大規模嘅 campaign 㗎啦。咁成個項目係3年嘅，咁所以話咧係最遲咧 出年亦都做埋第3次，因為今年亦都做咗第2次嘅。啱啱9月我哋做咗第2次嘅採樣。咁出年由而家開始去到出年，基本上我哋進行咧一啲實時嘅採樣啦，同埋出年年底前咧，亦都做埋第3次嘅採樣。即應該喺24年咧就會完成我哋3次嘅採樣之後咧，有一個嘅完結嘅報告。24年咧就喺呢個報告裏邊咧，就可以建議翻俾3地政府，我哋喺嚟緊究竟我哋要改善我哋嘅臭氧情況嘅時候咧，減排方向應該個重點係啲乜嘢？咁所以咧，大概喺24年底咧，我哋就會有一啲更加清晰嘅政策方案可以提交俾3地政府嘅。
好，唔該晒。請問仲有？
你好，經濟日報嘅，想請問下，其實而家你哋喺即係全港各區都會設置一啲即係監測點啦。其實總共即係海陸空有幾多個即係監測嘅點你嚟做？跟住同埋都提到就話，即係會喺一啲可能重大污染事件，即係高臭氧嘅日子去做一啲即係大規模嘅採樣啦。咁其實呢啲有冇話即係一年會做幾多次？即係會唔會係譬如每年高臭氧嘅日子就會做啊？定係即係好似頭先提到嘅，即係淨係年底嘅時候做一次咧，跟住同埋都想問下，其實即係預計啦，即係收集到呢啲唔同嘅數據啊，做完分析之後啦，其實點樣可以幫助到即係改善呢個臭氧嘅問題？唔該。
嗱，我先講一講嗱，我哋本港有18個空氣監測站，呢個我哋叫常規嘅空氣監測站，佢係不斷咁會運作嘅。咁但係咧，佢未必係會裝我哋而家最新購置嘅一啲嘅先進嘅儀器。因為數量有限嘅。咁除咗呢18個站咧，我哋都有一個超級站喺塔門嘅。咁所以有部分呢啲常規儀器咧，亦都會擺喺超級站。但係我哋亦都揀咗一啲特別嘅站點，例如大帽山頂啦。將來我哋亦都喺元朗邊陲嘅地方揾緊一啲嘅實驗嘅地點啦，合適嘅地點啦，係擺喺嗰度咧，做未來1年嘅一啲嘅採樣嘅工作。咁呢啲會係實時連續嘅採樣嘅工作。咁至於話一啲高污染日嘅大規模採樣咧，其實因為所需嘅人力物力好犀利嘅。頭先我講過啦，我要去80個唔同嘅點，係講緊成個大灣區，即係話我要派80隊人去唔同嘅地點喺同一日採樣。咁所以呢一個人力物力嘅需求比較大咧，係冇可能經常做嘅。咁所以咧，我哋係每年咧揀1至2次嘅啫。做1至2次咁去睇，因為我哋其實唔需要日日做嘅，因為你一定要係高臭氧日子，你採咗樣之後再做分析，你就會見到究竟我哋叫做佢嗰個 signature， 即係話佢有一個乜嘢嘅組分嘅特性喺度咁呢個特性咧唔會因為你日與日之間嘅變化咧會變化得好多嘅，咁所以我哋係有限度嘅。咁不過今年做完之後咧。我哋下1年咧都會揀另一個頭先我都講啦，唔係隨便一個日子嘅，我哋係預計啊邊日會發生高臭氧，嗰日就去做嘅。咁呢個係比較特別嘅研究方向嚟嘅。
唔該晒。係。
您好，上海台，您可以用廣東話回答。
廣東話、普通話也可以。
可以，對。好，第一個問題就是，其實我們知道今年那個珠三角地區的天氣的異常問題是非常明顯的。在非汛期的時候呢，我們是經歷了乾旱；在汛期的時候，降雨量明顯的提升。包括我們香港這個月以來，它的氣溫度非常高。第一個問題就是，我們這個測量到的情況跟天氣的情況，它之間的關係是怎麼樣的？這一套方法能不能幫助我們去作為去調節這個環境問題的一個參考標準？然後第二個問題就是這個項目它的迫切性在於哪裡？就是說為什麼我們在這個時候要花大力去研究這個問題？謝謝。
好，咁我回答用廣東話會容易啲，因為比較複雜。個成因，頭先我喺嗰個分析都已經，成因係同氣象有關嘅。污染物。尤其是第2次污染物，其實你嗰個物理個方向係好簡單，就係話你有排放，有污染物排放。如果你嗰個大氣個擴散條件係好，你排放咗就散咗啦，佢個濃度會自然會降低。 但係個氣象條件唔好，即係話個風好弱啦，佢個擴散條件好差，你排放出嚟嘅污染物就會留喺原本嗰個城市，走唔得。佢一路累積去到一定嘅量嘅時候，再經陽光嘅刺激呢，就會有呢一個光化學反應嘅情況，就產生臭氧。其實全國嗰個情況一樣，所以有冇臭氧、高臭氧嘅日子係取決於你當時嘅氣象條件。過去呢一個月由9月頭到現在，其實全國都受影響嘅，或者中國南方大部分都係受同一個氣象條件，因為有2個颱風。由9月頭有1個颱風，跟住剛剛嗰個梅花啱啱又走咗，去咗上海，仲有一個喺太平洋去日本，所以好特別係3個嘅颱風。其實每一次有颱風向住台灣嘅時候呢，我哋整個南方都係受影響嘅。咁所以呢個氣象條件呢係一個好決定嘅因素，但係我哋唔可以將個問題就賴咗氣象。本身我頭先講啦，呢個臭氧係2個問題嘅，氣象係一個，最主要就係我哋有污染源排放，我哋一定要減少個污染物。你唔減少污染物，其實係冇辦法做到呢一個改善臭氧。咁我亦都知道科學根據上邊呢，我哋叫協同嘅減排、減氮氧化物同埋減呢一個揮發有機化合物，即係 VOC， 主要係減呢2樣。就會令到我哋嗰個臭氧係會減低㗎啦。呢2樣嘢我哋過去好多年都減緊嘅，但係個故事就係冇減到咯。所以頭先你問點解而家有個迫切性呢？喺南方嚟講，喺珠三角地區，我相信我哋嘅 PM2.5差唔多全國已經係叫最好嗰一批㗎啦。香港嘅 PM2.5年均值水平已經係低過15個微克。咁已經係叫做幾好，但係個臭氧係不斷咁樣冇降到。咁我哋而家嘅期望就係話，我哋希望呢，我哋嘅政策減排嘅政策喺2025年可唔可以令到個臭氧係達峰呢？如果我要2025年臭氧達峰，我哋嚟緊呢幾年其實就要不斷要推一啲減排嘅方案，有效嘅減排方案，令到嗰個臭氧真係可以控制得到。咁所以點解我哋會咁迫切喺呢幾年要做一個大規模嘅實驗？唔單止去睇下究竟嗰個成因係點樣啦，亦都因為我哋不斷咁樣去監察嘅時候呢，我哋都會去睇得到究竟係咪達緊風啊？即係如果我哋去到做到24年，咦，真係見到個臭氧狀況開始達風咯喎，即係話證明呢，我哋提出嘅一啲嘅減排方案有效啦。咁個原因係咁樣。
好，明白，唔該。
你好啊，星島嘅。So I would like to know, as it mentioned that the ozone will cause a health problem. So will you give any suggestions to the public that how the public can avoid from such effects?
Okay. I think one of the things is a lot to do with reduce your exposure to the ozone. So EPD is putting out some of the forecasts of what is going to happen in the next few days. We at HKUST also having something at high resolution. But one of the things we find is that if you look at that, and when you know that the air quality is not good, you close the window, use more filtration system, that can significantly reduce your exposure to the ozone and that type of thing. And also, looking at the variation, you plan your activity. Like a lot of people like jogging. If you know that that is a really bad day, I would think that if you really want to jog every day, try to arrange, maybe do it in the morning. So when you understand more, you can manage the exposure and then reduce the health effect. But in the long term, the most important thing is still, we want to be able to reduce the overall thing. That is the thing we are getting help from these control measures.
好，唔該晒。時間關係，可能只可以問多1個問題。
南方報業傳媒集團嘅，我想了解下關於呢一個項目咧，有講過係粵港澳大灣區嘅合作啦。咁我想知道喺呢個合作嘅過程當中，各個內地嘅各個高校同香港科大以及喺香港嘅環境署、衛生署呢邊、環境署呢邊啦，咁係一個階段性嘅分工合作啊，定係話我意思係話，即係話大家負責採樣，然後集中俾邊一間高校去研究呢啲微粒，定係話大家各自採樣，然之後各自去研究呢啲微粒，再去歸總數據咧？唔該。
我哋今次係好着重係團隊合作，所以咧雖然話採樣團隊去每一間院校啦，其實內地暨南大學都有幫我哋喺廣州都有幫我哋做採樣嘅工作嘅，地化所廣州嘅地化所亦都有幫我哋做一啲嘅化學分析嘅，即係有啲採樣罐我哋係擺咗喺廣州去做分析嘅，所以我哋係同步香港、廣州都做分析，又可以有一個實驗室對實驗室嘅對比。所以今次我哋呢個項目係好強調個合作同互補性。最後收集咗咁多數據呢，我哋亦都有另外一個團隊呢，淨係做數據分析。咁呢個團隊呢，就會收集咗咁多嘅唔同嘅研究團隊啦、採樣團隊嘅數據之後呢，去俾翻一個嘅完整啲嘅分析，同埋個結論究竟係啲咩嘢？當然啦，喺呢個過程裏邊呢，其他嘅採樣團隊都會參與嘅，所以我哋每一年呢，都會開一次嘅督導委員會嘅會議。其實每一個採樣團隊會去報告翻啦，佢哋嘅工作啦，俾我剛才介紹啦，有8位嘅科學家、專家喺個督導委員會去評審究竟我哋嘅工作個進度係點樣啦，亦都係俾翻一啲指導嘅方向喺下一個階段可以點改進亦都去點樣去分析究竟我哋個數據反映緊一個乜嘢嘅現況。咁所以呢，簡單啲嚟講呢，今次我哋呢個研究計劃呢，唔係各自為政嘅，係香港環境保護署同埋兩邊廣州廣東嗰邊政府啦、特區政府啦、澳門特區政府啦，係政府主導嘅。政府主導，所以呢，我哋係邀請每一個嘅參與嘅團隊呢，係一齊合作去幫我哋手因為佢哋真係嗰方面嘅專家咁我覺得呢個係可以係一個先例，就係話官學甚至咧係有啲產業嘅，因為有一啲嘅我哋都要請一啲嘅商業嘅團隊啦，去幫我哋做一啲嘅聯絡嘅工作嘅，係3方面合作嘅一個先例。
好啊，唔該晒咁多位。咁時間關係咧，我哋嘅答問時間嚟到呢一度啦。We can continue to interview our guests during the media tour. So please be seated. 跟住落嚟咧，我想將時間交俾馮志雄教授，科技大學。因為咧，馮教授會為我哋咧講解一陣間我哋究竟去邊同埋睇啲乜嘢嘅。大家好快了解咗，我哋就會成行啦。
好多謝各位。頭先我哋都講咗啦，我哋會有個 site tour 嘅。咁就因為個 site tour 就即係都比較狹窄嘅，咁我哋會分成2隊 ，Group A、Group B。咁 Group A 嘅 first one 咧就會睇，就響呢度出咗去行落少少，大約50米度，就會睇我哋嘅 super site。喺個 super site 嗰度有好多 advanced instrument， 同埋有個激光雷達，同埋有個 drone 話俾大家聽點樣做呢啲 measure 嘅，就喺呢度。咁然後Group B 咧就會去我哋個 VOC lab 嗰度睇嗰啲 canister 點樣做化學分析。咁每一個 site visit 咧就大約25分鐘。咁去 Group B 呢一個 VOC visit， 大家落到出咗呢個大門口嘅時候有個 coach， 咁就去翻我哋個 main campus， 大約就3分鐘嘅車程到嘅啫，比較短嘅，就 take you there。Go there for about 25分鐘，咁就會嗰個 coach 就會 take you 翻嚟，就 visit 翻呢個 super site， 而 super site 嗰個 group A 咧就會去呢個 VOC lab， 大家 swap 翻嘅。咁呢個就係個 site tour。咁頭先都講咗少少㗎啦，我哋有個 VOC lab 啦，有個 site 啦，有 helicopter 嘅 measurement 啦，亦都有 drone 嘅 measurement， 響海陸空3地呢啲咁嘅 measurement， 做晒呢啲咁嘅 measurement。咁頭先都講咗。咁我哋做晒啲 measurement 咧，就會 put 落一個頭先就講咗點樣用呢啲數據啦。咁其中一個數據分析就係 put 落呢一個數學模型。
OK 喺呢個數學模型嗰度咧，就我哋就等於頭先講咗嗱，呢啲箭嘴就係個風啦，就係氣象嘅條件。咁然後就會有唔同嘅 pollutant 就喺呢個珠三角嗰度吹來吹去。咁我哋呢個數學模型咧就會反映到成個珠三角究竟嗰啲污染物嗰個濃度同埋幾時會發生。咁嗱呢個就係嗰個某兩個 station 嗰個。頭先 Kenneth 都講過㗎啦，紅色就係嗰啲 measurement， 而嗰個綠色嗰啲線咧就係嗰個數學模型。咁而呢個數學模型咧就會 predict OK 7日之後 OK 嗱，而家今日係9月19號，我哋 predict 到聽日嘅 ozone 都唔係低嘅。OK 咁等於頭先 Alexis 講啦，如果你走去跑步，咪響呢啲低嘅時間咯，響高嘅時間唔去跑步啦。咁呢個就會有7日嘅數據。咁如果我哋 predict到7日嘅數據，呢啲咁嘅高嘅，咪出去做呢個 field campaign。OK 就成個模式，同埋呢個數學模型有個好處咧，就可以喺個減排嗰度，就喺個數學模型嗰度，究竟邊一隻化學物會令到呢個減排做到 maximum effect。OK 就係數學模型有咗呢啲數據，有咗呢啲咁嘅 understand 咗我哋嗰啲光化合嘅作用啊，咁樣嘅時候，我哋就可以每一個污染物睇下佢嗰個令到嗰個 ozone 嗰個 formation 嗰個 concentration 幾多，然後減邊一個污染物係最 effective。OK 呢個就係希望。成個呢啲咁嘅 measurement 同埋數學模型咧，就幫呢個珠三角解決呢個臭氧嘅問題。OK，咁嗱我都就停喺呢度，咁就大家就我希望喺呢度大約就分 Group A 同埋 Group B。嗱邊個係 Group A？